Download this code from codegive.com, link in the description below. Creating a text parser in C with ANTLR, a comprehensive tutorial. This tutorial will guide you through the process of creating a text parser in C using ANTLR, another tool for language recognition. We'll cover the following topics. 1. Introduction to ANTLR*. What is ANTLR, its purpose, and benefits. 2. Setting up the environment*. Installing ANTLR and the C runtime. 3. Defining the grammar*. Creating a grammar file that defines the structure of our language. 4. Generating the parser*. Using ANTLR to generate C code from the grammar. 5. Writing the listener/visitor*. Implementing the listener or visitor to process the parsed data. 6. Building and running the parser*. Compiling and executing the generated parser. 7. Error handling*. Implementing basic error handling. 8. Example project, a simple calculator, a complete working example to illustrate the process. 1. Introduction to ANTLR. ANTLR is a powerful parser generator that simplifies the creation of compilers, interpreters, and other language processing tools. It takes a formal grammar specification as input and automatically generates source code for a lexer, tokenizer, parser, and tree walker. Benefits of using ANTLR*. Grammar-based approach. Focus on defining the language's structure rather than writing complex parsing logic manually. Automatic code generation. Reduces development time and minimizes errors. Support for multiple languages. ANTLR can generate code in Java, C, Python, C++, JavaScript, Go, and more. Error recovery. ANTLR provides mechanisms for dealing with syntax errors gracefully. Tree construction. ANTLR can automatically generate parse trees or abstract syntax trees, ASTs. Listener and visitor patterns. Offers flexible ways to traverse and process the parsed data. Key concepts. Lexer, tokenizer breaks the input text into a stream of tokens. Tokens are the smallest meaningful units, example keywords, identifiers, operators, numbers. Parser. Analyzes the token stream and builds a parse tree based on the grammar rules. Grammar. A formal specification of the language's syntax, defining the valid sequences of tokens and their relationships. Parse tree. A hierarchical representation of the input text, showing how it conforms to the grammar. Abstract syntax tree, a simplified representation of the parse tree, focusing on the essential structure and meaning of the code. Listener. An interface that provides callback methods for entering and exiting grammar rules. Used for simple processing tasks. Visitor. An interface that provides methods for visiting specific nodes in the parse tree. Offers more control over the traversal and processing. 2. Setting up the environment. Before you can use ANTLR, you need to install it and the C runtime. Installing ANTLR*. 1. Download ANTLR*. Go to the ANTLR website, https://www.antlr.org/ https://www.antlr.org, and download the ANTLR tool. The current version is ANTLR v4. 2. Set up the ANTLR environment variables*. Set the ANTLR_home environment variable to the directory where you installed ANTLR. Add %ANTLR_home %\ANTLR 4.13.1 complete.jar, replace 4.13.1 with the actual version number, to your class path environment variable. Add %ANTLR_home %and %ANTLR_home %\bin to your path environment variable. The bin directory may contain helper scripts if the distribution has it. 3. Verify the installation *. Open a command prompt or terminal and type ANTLR 4. If ANTLR is installed correctly, you should see help information. B. Installing the ANTLR C runtime *. The ANTLR C runtime is a set of C libraries that provide the core functionality for lexing and parsing. You'll need to download and build it separately. 1. Download the C runtime source *. Go to the ANTLR GitHub repository, https://github.com/ANTLR/tree/master/runtime/c, https://github.com/ANTLR4/tree/master/runtime/c, and download the contents of the runtime/c directory as a zip file or clone the entire repository. 2. Build the C runtime *. The building process can vary slightly depending on your operating system and C compiler. Here's a general guideline for a Linux environment using GCC. *. Open a terminal and navigate to the directory where you downloaded the C runtime source. * Create a build directory, mkdir build. * Change to the build directory, cd build. * Run cmake, make. * Build, make. * Install, optional sudo make install. This might install the runtime libraries to a system-wide location, making them available to other projects. You can also skip this and link against the library directly in your project. For Windows, you'll typically use a CMake generator for Visual Studio or MinGW, if using GCC-based development. The steps will be similar: create a build directory, use CMake to configure the build, and then build the project using your IDE or MIS-build from the command line. You might need to specify the generator using Visual Studio 17 2022, or your corresponding Visual Studio version, in the make command. 3. Include and link the C runtime * in your C project. You'll need to *include * add the directory containing the ANTLR 4 runtime.h header file to your include path. This allows your code to find the ANTLR C runtime header files. *link link against the ANTLR C runtime library, usually named libANTLR4 runtime.a or libANTLR4 runtime.so on Linux, or ANTLR4 runtime.lib on Windows. This provides the necessary runtime functions for lexing and parsing. You'll typically specify the library location in your compiler/linker settings. 3. Defining the grammar. The grammar defines the syntax of the language you want to parse. ANTLR grammars are typically stored in files with the .g4 extension. Let's create a simple grammar for a basic calculator that supports addition, subtraction, multiplication, and division. Create a file named calculator.g4 and add the following grammar. Explanation *. Grammar calculator declares the name of the grammar as calculator. This name is important because it will be used to name the generated classes. *Parser rules *. These rules define the structure of the language. *Expression. An expression is a sequence of terms separated by plus or dash operators. The asterisk means 0 or more occurrences. *Term. A term is a sequence of factors separated by asterisk or slash operators. *Factor. A factor can be a number or an expression enclosed in parentheses. *Lexa rules *. These rules define the tokens. *plus, minus, mul, div, lparen, rparen. These are literal tokens representing the arithmetic operators and parentheses. *Number. A number is a sequence of digits, optionally followed by a decimal point and more digits. The makes the decimal part optional. *ws, wit spaces, tabs, carriage returns, new lines, is ignored using the -skip command. 4. Generating the parser. Now that we have the grammar, we can use ANTLR to generate the C code for the lexer and parser. Open a command prompt or terminal and navigate to the directory containing calculator.g4. Then, run the following command. This command tells ANTLR to *language = C, generate code in C. *calculator.g4, use the calculator.g4 grammar file. ANTLR will generate the following files. *calculator lexer.c, *calculator lexer.h, *calculator parser.c, *calculator parser.h, *calculator.tokens, *calculator listener.h, *calculator base listener.h, *calculator visitor.h, *calculator base visitor.h. 5. Writing the listener/visitor. After generating the parser, you need to provide a way to process the parsed data. ANTLR provides two main mechanisms for this: listeners and visitors. Listeners are a simple way to respond to events during the parsing process. They provide callback methods that are called when the parser enters or exits a grammar rule. Listeners are suitable for simpler tasks, like building a basic AST or performing some simple validation. Visitors provide more control over the traversal of the parse tree. They allow you to explicitly visit specific nodes in the tree and perform custom actions. Visitors are useful for more complex tasks, such as code generation, semantic analysis, or complex data extraction. For our simple calculator example, let's use a visitor to evaluate the expressions. We'll create a calculator visitor that visits the nodes of the parse tree and calculates the result. Create a file named calculator_visitor_impl.c and add the following code. Explanation **** includes the necessary header files, including the ANTLR generated headers. Calculator context *** a struct to hold the intermediate and final result of the calculation. This is passed as the visitor context. Create calculator context, and free calculator context, functions to allocate and free the calculator context struct. This is crucial for managing memory. Visit expression, visit term, visit factor, these are the visitor methods for each grammar rule. Each method takes a calculator visitor pointer and the context, parse tree node, for the corresponding rule. They recursively call the visitor methods for the subrules to evaluate the expression. They perform the appropriate arithmetic operations based on the operators found in the parse tree. The etoff function converts the number string to a double. Error handling for division by 0 is included. Calculator visitor_create. Creates an instance of the calculator visitor and initializes its function pointers. This is essential for creating a properly configured visitor. It also allocates the context that will be used throughout the traversal. Calculator visitor_free. Frees the memory allocated for the visitor and its context. This is crucial for preventing memory leaks. Create a header file named calculator_visitor_impl.h with the following declaration. 6. Building and running the parser. Now we need to create the main function that will parse the input text and use the visitor to evaluate the expression. Create a file named main.c and add the following code. Explanation **** includes the necessary header files, including the ANTLR generated headers and our visitor implementation. Main function **** takes the expression as a command line argument. Asterisk creates an ANTLR for _input_ stream from the input string. Asterisk creates a calculator lexer and a common token stream to tokenize the input. Asterisk creates a calculator parser to parse the token stream. Asterisk calls calculator parser_expression, to parse the expression rule, creating the parse tree. Asterisk crucially asterisk creates an instance of the calculator visitor impl using calculator visitor_create. Asterisk calls the visit function to traverse the parse tree using the visitor. This is where the evaluation happens. Note that ANTLR C runtime's visit is used in visit, tree, visitor. You will need to implement a way to call your visit expression method on the root of the tree using a generic visit function. Alternatively, you can restructure the logic to directly call visitor-visit expression, visitor, tree. Asterisk prints the result obtained from the visitor. Asterisk important asterisk frees all the allocated memory using calculator visitor_free, calculator parser free, common token stream free, calculator lexer free, and ANTLR for free input stream. This is crucial to avoid memory leaks. Compilation and linking asterisk. Compile the code using a C compiler, like GCC or Visual Studio. You'll need to include the ANTLR runtime header files and link against the ANTLR runtime library. The exact commands will depend on your operating system and compiler. Here's an example compilation command for Linux with GCC. Replace /path/to/ANTLR4/runtime/C with the actual path to the ANTLR C runtime source. LM is needed for the math.h library. For Windows with GCC, min-gw. For Windows with Visual Studio, you'll typically create a project, add the source files, set the include directories and library paths in the project settings, and then build the project. Running the parser asterisk. After compilation, you can run the parser with an expression as a command line argument. The output should be 7. Error handling. The provided code includes a basic division by zero check. For more robust error handling, you can customize ANTLR's error reporting mechanism. You can implement a custom error listener to handle syntax errors and provide more informative error messages. Here's a basic example of a custom error listener. To use the custom error listener, modify main.c like this. Now, if you provide an invalid expression, the custom error listener will print a more informative error message. 8. Example project, a simple calculator, complete code. Here's the complete code for the simple calculator example, including all the files. Calculator.g4 asterisk. Calculator visitor.h asterisk. Calculator base visitor.h asterisk. Calculator visitor impl.h asterisk. Calculator visitor impl.c asterisk. Main.c asterisk. C. Includes sto.h.